making formulas for ionic compounds. One thing we want to do is just sort of review what we should expect with an ionic compound. Um, Ionic compounds are mainly what we think of as salts. And again, salt is a generic term. It does not mean just table salt. But when we think of salts, we think of crystalline solids with high melting points. They don't have to be white, they can be colored. Many of them are water soluble, and in solution, they are going to exist as ions. And that's going to be important. They're actually going to break up and form ions in solution, which of course are charged particles. And we call these ions electrolytes. They allow water to become an electrical conductor. Ionic compounds are good conductors if they are molten or if they are aqueous, meaning they're in solution. They are typically non-flammable, although they may be oxidizers if you have oxygen in the formula. And they typically don't have any odor. So these are the kind of compounds we're going to look at making formulas for. Now, it's going to be important to be able to use the periodic chart. And we're going to be looking at the A groups in the periodic chart, 1A, 2A, and then 3A through, I'm going to be calling this 8A. In some other periodic charts, you will see them start with group 1, 2, and this will be 13 through 18. But the A groups really are going to work out well for us. For starters, we're not going to look at the transition metals, which in this case are the B groups, and so I'm going to go to another periodic chart where I have eliminated the transition metals. So when we look at this periodic chart, these numbers reflect the periods on the periodic chart, and every period we are adding an additional layer or energy level of electrons. So for example, potassium is in period 4, and there are actually 4 energy levels of electrons. We are interested in the electrons that are in the highest energy level, which tend to be the outer electrons, and we call these the valence electrons, are in these highest energy levels. The valence electrons, the number of valence electrons will be equal to the group number, and these are group numbers up here. So if we look at lithium, lithium is going to have 2 energy levels because it's in the second period. The first period is going to have 2 electrons in it, which will be the ones that were there for hydrogen and helium, and the second energy level will have just 1 electron that belongs to lithium's valence shell. On the other hand, if we look at sodium, sodium is in the third period. It has 3 energy levels. It has 2 electrons in the first energy level, which are the ones from hydrogen and helium. And then it has 8 electrons in the second energy level, which are the 8 electrons put in here. And then it's going to have 1 for its outer. Notice it is in group 1, and both lithium and sodium have 1 electron in their outer shell. It will be the same as you keep on going down. It's just that the 1 electron will be further away from the nucleus. Again, if we look at group 7, for example, if we look at chlorine, chlorine is in the third period. It has a total of 3 shells. The first shell again has only 2 electrons. The second shell will have all 8 electrons. And the third shell will have 7 electrons. If we look at helium, neon, argon, and so on, we have what we call full outer shells. For helium, we've got 2 electrons in that outer shell, and that's all it can hold. For neon, we have 2 and then 8. For argon, we have 2 8, and 8. And 8 electrons in an outer shell is called an octet, and this is considered to be a full outer shell. And we look at that because these elements are what we call inert or noble gases. They're inactive. They don't want to gain electrons, they don't want to lose electrons. But we see all the other elements seem to want to do that. And in fact, if sodium could lose this one electron, it would have 8 electrons in its outer shell, and it would look just like neon. And chlorine, on the other hand, could do the same thing by gaining 1 electron, and if it gained 1 electron, it would look just like argon. So the idea will be to gain or lose electrons to look like the nearest inert gas. Now here is a picture of what we call the Lewis dot symbols, and these are showing those outer valence electrons. And here is our full outer shells. And you can see that fluorine needs 1 more, oxygen needs 2 more, nitrogen needs 3 more, and what we don't see is what's underneath lithium or what's underneath sodium. But if these elements can lose that 1 electron, they go back to a previously filled inner shell. The charge that these elements will get is going to be related to their group number. So group 1A, 2A, and aluminum in group 3A, their charge will be equal to the group number. So aluminum will be a +3 ion, group 2 will be +2 ions, and group 1 will be +1 ions, which means they will lose that 1 electron or those 2 electrons. For group 5 through 8, they will want to gain electrons. Group 5 will want to gain 3, group 6 gain 2, and group 7 gain 1. And since electrons are negative, these are the charges that you will get. So you can take the periodic table that is perhaps in front of your textbook and add these charges to group 1, group 2, group 3, and group 5, 6, and 7. So positive charge for group 1A, 2A, and aluminum is equal to the group number, and negative charge for group 5, 6, and 7 is equal to the group number minus 8. So if you're in group 5 minus 8, your charge will be minus 3. So we're going to see how we can use that information in making formulas for compounds, for ionic compounds. For starters, we're going to look at binary salt compounds, where we will have a metal and a nonmetal. The metals lose electrons fairly easily, and they actually give them to the nonmetals. And we're going to look at how that works. So if we think about sodium, sodium has 11 electrons, and if you put them in shells, you'd have 2, 8, and 1. Chlorine has 17 electrons, 2, 8, and 7. They both want to have 8 electrons as a full outer shell. And sodium is going to end up giving 1 up to chlorine. And when it does that, it will have a positive charge. Again, 11 protons, but 2 and 8 with a +1 charge. And notice it shrinks in that process. And chlorine will have 2, 8, and 8. Of course, it has 17 protons, so with the with the 18 electrons, it will have a -1 charge. Now, The charges are equal and opposite, and that is the formula for the compound, NaCl, and that's why it works. Let's look at another one, and that is magnesium chloride. Magnesium is element number 12. Chlorine is element 17. So magnesium has 2, 8, and 2. Chlorine has 2, 8, and 7. Magnesium will want to get rid of 2 electrons, but chlorine will only want to accept 1. So what has to happen is we actually need to supply 2 chlorines to do this. So magnesium will give up 1 electron each to 2 chlorines, and you will form a magnesium plus 2 ion, and then you will form 2 chloride minus ions, which gives us a ratio of MgCl2, the formula for magnesium chloride. Now, this is not how I'm going to expect you to do these problems, but you should look at magnesium and know that it is in group 2, give it a plus 2 charge. Know that chlorine is in group 7, and know that it gets a negative 1 charge. And then you will take the value of these charges and cross them. So you will give magnesium a 1, chlorine a 2, and that will be written without the subscript 1. The subscript 1 will be assumed. So let's look at, again, positive charge is equal to positive the group number, and this is for group 1A, 2A, and for the aluminum in group 3A. And the negative charge is the group number minus 8 for group 5A, 6A, and 7A. Group 4 is a little bit messy. There's some metals and nonmetals in that group, and we're not going to consider those at this time. So here are some examples of what you should be doing, and this is a way to practice going through this. Sodium is in group 1, you assign it a plus 1 charge. Bromine is in group 7, you assign it a negative 1 charge. The charges are equal and opposite, so they just fit together. You've got the same number of positive and negative charges. But calcium is in group 2, whereas iodine is in group 7. And now you need to cross charges. You're going to need 1 calcium and you're going to need 2 iodides. Barium is in group 2. Oxygen is in group 6. These are equal and opposite charges, so you don't need to cross them. Aluminum is in group 3. Chlorine is in group 7. You need 1 aluminum and you will need 3 chlorides. So this is the way you want to go through these programs. And this is the way you will be looking at this. So hopefully this will help.